Thus far, we've examined only the primary schematic of primary resistor or reduced voltage starters. Let's take a look at some sample pilot schematics that govern the operation of primary resistor reduced voltage starters. Our first ladder logic example of a primary resistor reduced voltage starter features an operator-initiated start, followed by an operator-initiated transition from start to run mode. Rung 1 and 2 consist of a 3-wire control circuit governing the start contactor only. Rung 3 and 4 consist of a 3-wire control circuit governing the run contactor only. Note the normally open S2 contact in rung 3. This prevents an operator from closing the run contactor without having first closed the start contactor. When an operator presses and releases the start push button, the S contactor coil is energized and its associated contacts change states. The S primary contacts close and the primary resistors limit inrush current. The S1 holding contact closes, as does the S2 interlock in rung 3. An operator witnessing the motor and applied load come up to rated speed then initiates a transition to run mode by pressing and releasing the run button. When the R contactor coil is energized, the R primary contacts close and the primary resistors are switched out of the circuit. Full voltage is applied to the motor. The R1 holding contact closes. Note the E-stop, stop, a normally closed overload contact, serves to de-energize both the start and run contactor coils, thus opening both primary contacts and de-energizing the motor. The fundamental flaw to our system as currently implemented is that it relies upon the judgment of the operator to initiate the transition from start to run. Operators, like most of humanity, have a reputation of being fickle mushheads and cannot normally be relied upon to make consistent and sound judgments based off only visual and audible clues. It is for this reason the run push button has been replaced in our second iteration with a rotational speed switch that closes when the motor has reached an acceptable transition speed. Note, since the operator's subjective judgment has been removed, it's really not necessary to include the S2 interlock in rung 3. The operator still initiates a start by pressing and releasing the start push button, however, only when the motor has reached the set speed of the rotational speed switch. Does this system automatically initiate a transition from start to run mode by bypassing the bank of primary resistors. Note the R1 holding contact ensures full voltage is still applied to the motor should it experience any lulls in speed after the transition from start to run. The setting of the rotational speed switch could be reduced such that the transition occurs early, or the setting of the rotational speed switch could be increased such that the transition occurs later depending upon the needs of the mechanical system and the desire to limit disturbances on the electrical distribution network. Note that this transition could also be time-based rather than speed-based. We'll discuss primary resistor reduced voltage starters using timers in later lectures. Finally, consider a primary resistor reduced voltage starter that uses not one, but 2 or more banks of primary resistors to limit inrush current in a stepwise manner. When the S or start contactor only is closed, both primary resistor banks, A and B, serve to limit inrush current. After a predetermined period of time, or after the motor has reached a predetermined speed, the RA primary contactor closes and bypasses the A bank of primary resistors, leaving only primary resistor bank B to limit inrush. Finally, after another longer period of time, or after the motor has reached a greater speed, the RB primary contactor also closes and bypasses the B bank of primary resistors. Full voltage is applied to the motor. This stage approach therefore serves to limit inrush current and mechanical stresses to the applied load via a graduated approach. Note, more stages would increase the number of gradual steps, however, directly increase the cost, weight, size, and complexity of this system. Here's an example of the pilot ladder logic diagram governing the behavior of this 2-stage primary resistor reduced voltage starter using 2 rotational speed switches. Rotational speed switch A has a setting less than rotational speed switch B. I leave it as an exercise to the viewer to determine how this staged primary resistor reduced voltage starter operates using this ladder logic diagram. You should observe that when an operator initiates a start, both resistor banks A and B limit inrush current. At the speed setting of rotational speed switch A, resistor bank A should be switched out. At the speed setting of rotational speed switch B, both resistor banks should be switched out and full voltage would be applied to the motor. Here's a graph of line current for a regular full voltage starter for a lightly loaded motor. The vertical scale is set to 5 amps per division and the horizontal scale is set to 0.2 seconds per division. Notice the huge current draw, peaking out around 12-ish amps upon being instantaneously and directly connected to full voltage. Additionally, note the motor accelerates briskly and reaches a stable current draw at maybe 3.5 to 4-ish divisions, meaning it took the motor less than a second to accelerate the applied load. This wouldn't be the method of choice for a fragile electrical distribution network or applied loads necessitating controlled acceleration. In contrast, consider the graph of line current for a 5 ohm primary resistor reduced voltage starter used on the same lightly loaded motor. The vertical and horizontal scale are set to the same respective 5 amps per division and 0.2 seconds per division. Notice the motor now takes 5.5 to 6-ish divisions, or around 1.2 seconds to accelerate the applied load. Additionally, note that current draw peaks out at only 9 amps. The primary resistor reduced voltage starter therefore serves to limit inrush current demand and mechanical stresses to the applied load. Here's both curves superimposed on one another so you can compare the two methods. The full voltage starter is in blue. It is characterized by a substantial inrush and a brief acceleration period. The 5 ohm primary resistor reduced voltage starter is in yellow. It is characterized by less inrush and longer acceleration. If we increase the resistance of the primary resistor reduced voltage starter, we can expect inrush to decrease and the acceleration period to increase. Here's the graph of line current for a 10 ohm primary resistor reduced voltage starter used on the same lightly loaded motor. The vertical and horizontal scale are set to the same respective 5 amps per division and 0.2 seconds per division. Notice the motor now takes 8 to 8.5-ish divisions, or just under 2 seconds to accelerate the applied load. Additionally, note that current draw peaks out at only 7 amps. The primary resistor reduced voltage starter with increased resistance therefore serves to further limit inrush current demand and mechanical stresses to the applied load. Here's all 3 curves superimposed on one another so you can compare the methods. It's kind of busy, but you should get the picture. The full voltage starter is in blue. It is characterized by a substantial inrush and a brief acceleration period. 5 ohm primary resistor reduced voltage starter is in light yellow. It is characterized by less inrush and longer acceleration. The 10 ohm primary resistor reduced voltage starter is in darker yellow. It is characterized by even less inrush and even longer acceleration. Alright, this about wraps up our introduction of primary resistor reduced voltage starters. Again, be prepared to revisit reduced voltage starters using timers once we've gotten a basic introduction to the timer relay. In conclusion, this lecture took a brief look at primary resistor reduced voltage starters. We learned reduced voltage starters are used to reduce inrush current and modify acceleration and starting torque characteristics. The primary resistor reduced voltage starter method uses resistors in series with a motor intended to carry primary current. When started, primary resistors drop a portion of the applied voltage, and once the motor reaches a predetermined speed or accelerates for a predetermined time, are switched out. Remember to review these concepts as often as you need to really drive it home. Imagine how well lab will go if you know what you're doing. Thank you very much for your attention and interest, and we'll see you again during the next lecture of our series. Remember to tell your Lazy Lab partner about this resource, and be sure to check out the Big Bad Tech channel for additional resources and updates.